All right. This is part two. Part one was interrupted, and we are here to continue where we ended. All right. So, without even wasting our time, so after the end, after the end of the all the explanation that we're about to give, we'll answer all these questions. All right. So these questions we're able to see they came in 2022. All right. So that is 16 marks. Imagine after watching the video you're able to get 16 marks. That's progress. All right, pay attention. Okay, so answer all of these questions. So this is just lecture 1. So you'll be finding all your lessons here. Elisa, are you able to see what is there? Are you able to see Elisa? Okay, that's good. Then what you are going to do, I gave an example to say in terms of, we can also present these things in terms of deltas. All right, let's say we have a curve there. All right, so since that is a curve we have there, so we can say, we can present something here. Okay, so let's say I have a secant like that. Okay, okay, so now I have those points. So I have the point there and also the point there. All right, so since these are my points, I'll say, they say this is point P, this is point Q. All right, so what I'm going to do is I'll say in terms of delta notation. So I'm saying delta notation. Okay, in terms of delta notation, what we are going to do is we are going to what, to write the coordinate. So at this point the coordinate will be the same x1 we have, all right, comma the function what, fx, like that. This is in terms of deltas. Then again at that point q, we have the function, the function of x and also for y as follow. All right, so there was change, so we say delta, that change delta x, like that, comma, then for y we put the same thing, the f of the delta change in x then will result in also in change of what, y. So that's the reason why we are writing like that. Okay, so now these are the points we have. So we can say now the gradient of a secant, this line secant, so we are saying this is our secant line. Then the gradient there, we are going to say, we know gradient is change in y over change in x, so we are saying, so the gradient now of this secant is equal, is given as what, change in x, so final y minus the initial y, so final y is what, f of what, change in what, x. All right, delta what, x, like that, then minus the change, the first y was what, just f of x, so we'll just write f of x, then over, all right, over, you do what, we have there x plus delta what, x, then minus the same x, you see this x we have as the initial, so that's x1 to say. I won't really show x1, but I'll just write like that. Okay, so then from there what we are going to do is we'll write the same thing the way it is, that is x plus 8 delta x, in short change in x, over what, I mean minus f of the same function, then over, we can see this and this goes, so we just remain with what, delta change in x. So this is what we have been doing, like that h you see in the first principle, that's change in x, also this delta is change in x. All right, so from there then we are saying now we can replace now, since this is also change in what, um since this is also, I can factor, I can multiply throughout by that f of x on top there, so that would be what, f of x minus plus to say plus f, which is fy, this f, then delta x, right, minus f of what, x, like that. So then over, then we have what, delta x, like that. So that's not 8, it's delta, guys. Alright, that's delta. So then you can see this one and this one will go, so remain with just f of what, delta x over what, delta x, like that. So this can be written as, so this f we are able to see f of x, so I can simplify there. I'll say f of x, like that, then delta what, that's delta, guys. Okay. Yeah, this is delta. So we'll say so that is just, I'm multiplying now, then I'll bring the delta thing there. Alright, then over the same delta x. Alright, so this is equal to what, this f of x we know it's y, right? So I'll write just delta what, y, or y delta. So I'll just write delta y, because f of x is y, then I'll write what, delta x, like that. So this means that delta is just a change of something, so there's delta y over delta what, x. So meaning that this is change in y over change in x, and that will give us what, our gradient. So that's about delta things. Don't get confused when we tell you to say find the delta of something. No, that's about, delta is just a change of something, like just like, that's just a symbol for like a triangle thing, you know. That's the delta. Alright, delta is this. So that's delta notation. So which is equal to this thing. Alright. So that's the delta notation. Okay. So now what you're going to do is, suppose we have these points. Alright, we have been given points. Let's say this is the there at that point. The points now are what can I say? The points are what? Let's say this is 4, alright, comma 16. Then here the points are let's say the points are now what can I say? 3, comma 9, like that. Okay, so we are saying to find the gradient. Now that you have been doing the process of finding the gradient is what we call differentiation. So we say m1 y2 minus y1 over x2 minus what, x1. So y2 is what, 16, minus y1 is 9, over x2 is 4, then x1 is 3. So this will give us what, that's 7 over 1. That will just give us what, 7. So that's a gradient of a constant number. It is giving us constant, but the issue of these delta things, they are coming in that they are no numbers. That's why we have these delta things. Alright, so now we can dive. We have seen how we derived the first principle. Now it's just about going through questions now. So shall we start with questions? So the first question that we are going to do together is y is equal to what, x squared. So using first principle, so using first principle, we want to what, to differentiate this. So the first principle states that with the formula f prime of x is equal to what, is equal to lim as x approaches 0, or constant number approaches 0, of f of what, x, then the change in x, that's change in y now. Alright, change in x result in change in y. So f of x, like that, the first function, then over h, like that. So that's our formula, right? So what you are going to do is, I'll proceed by saying lim as h approaches what 0. You write all these stages. So wherever there is x in this one, you put what this thing you're able to see there and subtract the same function. So what you are going to do is there is what here, this is squared, so I'll put open bracket, so I'll put x plus h. All right, so the whole things in the bracket here represent x, so wherever there is x, put that. So we are putting that squared, all right, minus the same function which is just the x squared. All right, then over h. So lim as h approaches 0, say we'll just multiply this one. So once you multiply that one, it will, once you expand it, to give you x squared plus what 2xh, like that, then plus h squared, then minus x what squared, like that, over h, like that. Okay, so we continue by saying lim as h approaches 0. So this and this can go, as you can see, then we remain with the 2hx. So I can even factorize from there. I'll factorize this, what is common there. All right, there's what is common, which is h. So I'll say h open bracket, there it will be 2x, right, then plus h, once you factorize there, then over h, like that. So we can see this h and this h goes. All right, so now this is where, now after the moment you replace that value of h as 0, then you leave the word lim. So I will say 2x. all right, so let me show you something that it is important what I'm doing. So I'll say now 2x, all right, plus 0. I've left the issue of that, then I'll remain with what 2x. So this is the dy dx of from the first principle. All right, okay, so next question. Suppose you are given now the equation as what, suppose you are given this function now. So suppose you are given the function. So these are just exercise from your lecture note after at the end. So we have what, y is equal to what 2x squared minus 3. So they are very simple, but we just need to understand something. So now what you are going to do is we'll say this, we'll replace wherever there is x, we'll replace what, that function. So we'll say as, so f of prime rim, all right, as h approaches 0. So we'll say we'll replace that value wherever there's x. So I'll say that is x plus h, all right, then squared, like that, minus 3. Then again minus the same function, which is what 2 open bracket 2x squared minus 3, like that. Okay, then over the same thing, so the over h, I mean. So that is it. Then from there I'll say lim as h approaches 0, then that will be what 2 open bracket. We saw how we expand that one. You just say x squared, then you add the two things inside, that is 2xh, then plus h what squared, like that, then minus 3, then this now negative will distribute into negative x squared, then there it will be plus 3. All right, then we have h there as the what, the denominator. So from there, then what we are going to do is we'll say lim as h what approaches 0, then I'll distribute that one, that will be 2x squared plus 4x what h, then plus 2h squared, like that, then minus 3 minus what 2x squared plus 3, all right, over h. All right, so what we are going to do, we can see things that are cancelled. There's the there's this 3 there, it is going with this one, there's this 2x is going with this one, right? So remain just with the rim as h approaches what 0, then that will be what I can even factorize, because I've remained with these things only. So I'll factorize what is common there. I can say 2, all right, I can say 2 if I want. So I'll say 2. Alright, if I want, I'll say 2. But before that, let me factorize something common so that I work with what I want to have. So h is common there, so I'll factorize h, open bracket. So that will be what? 4x. Alright, plus 2h, right? Then over h like that. So this will be what? Rem as h approaches 0. That will be what? This and this goes, right? So that will be what? 4x plus 2h. So now we agreed that as h approaches 0, so once you replace the value of x, forget about the rim thing. So you say 4x plus 2, then open bracket 0, which will just give us what? 4x. So that's the value we needed. Okay, so that is about this one. Let's go to the next question. Okay, so the next question now, these are questions now which are tricky, and it's important that you solve them. So it's very tricky question, but we are going to solve it. Alright, so they are coming from your tutorial sheets, the same lecture notes, so don't even say no. These ones are very standard for your exam. So suppose we have now f of x is equal to 1 over what? X minus 1, like that. So we are from first principle. Alright, so we are differentiating this from first principle. So what we are going to do is we'll say the formula gives us, from the formula definition, we say f prime of x is equal to rem as h approaches 0, then open bracket, change in y, that is just x plus the certain constant number, then minus the same function, then over change in what? The same x. So change in x is h. We discussed this. So now from there we are fine. This is the gradient, by the way, don't even get confused. So then from there we'll say we replace now. So lim as h approaches 0, so I'm removing this f. I'll just write what is supposed to be written there. Now that there's a function, so I'll say over. I'm interested where x is found. So wherever there's x, I'll put what? X plus h, like that. Okay. Then minus 1. Then again minus the same function, right? 1 over x minus 1, like that. Okay. So that is it. So that's the same function, right? Yes. So now from there, then I'll group the like terms. I mean, I'll see what is common there and also combine the two. So rem as h approaches 0, what is common there? So the common thing is what? What is common? So this one I can just group them. They are like terms, like that. Okay. So I'll say x plus h minus 1, like that. Open bracket, then we have x minus 1. So what is common there between the two? So this one goes into that once, because I've just brought the brackets there, guys. Don't get confused. I know someone might be lost. Just so from there, then what you're going to do is we multiply like that. So that will be now x minus 1. All right, then minus, or let me just remove these brackets. Okay, then minus. Okay, so negative 1 throughout by what? By this thing what we have here. So that is x plus h minus 1, like that. Okay, then this thing is being divided by the what? H. Even here I forgot, is being divided by h. Alright, I can be writing like this or just over. You choose. Alright, so I can choose to say it will be divided by h, like that. Okay, then from there I will say lim as h approaches 0. Alright, so I'm grouping the right terms there. So that would be what? I can even cancel from there, but before I cancel, I know I will confuse someone. So let me say x minus 1, then that minus negative, it will be distributed there. Alright, then minus h again, then minus that will be now plus 1, right? Then over we have what, open bracket x, right, plus h minus 1 open bracket x minus 1, like that. Okay, then from there we can see this one goes with this one, so again this one goes with this one, so remain with the negative h there on top. So we'll say lim as h approaches 0, so we have negative h there on top over, alright, over x plus h minus 1 open bracket. So by the way I need just, okay, then x minus 1, like that. Then this is equal to, so now as lim I'm removing the lim thing. So once I remove the lim thing, then forget about what, forget about the what's this but before that, let me do this, I'll say I know it is being divided by a certain h, if you have forgotten. So that one, this over here, I can reciprocate because it's dividing. It's more like it is over there, right? H. So this h has 1. So it will rotate and you become what? 1 over h, like that. Hope that is clear. Hope someone is not lost here. So then from there, what I'm going to do is, so I've changed this one, it has reciprocated. Then what I'm going to do is, I'll cancel this one and this one. They will remain with a negative there, right? So now this means that I'll even substitute where I will leave the lim word. The word lim, I'll leave it, then substitute wherever there's. So there's negative 1 on top of there. So then wherever there's x, I'll put like that. So there is 0 now. Here it's 0. So I'll just write minus 1 like that. So then there's what? X minus 1, like that. Okay. So this will finally give me negative 1 over x minus 1. So since there are 2, I'll write squared like that. Then I'll be done. This is the what? The final answer. Alright, so that is it about that one. Hope that was clear. Alright. So now the other question that we can solve is actually one of the interesting question. So the question is alright, so that is now, see, so we have the function f of x is equal to x minus 1 over x, like that. So this is not difficult. What you can do is work out this part and also work out this part different. All right, that's what I can encourage, otherwise it will confuse you as you'll be solving. So I'll choose this part to work alone and also work alone in this part if you want. All right, so if you want you can work it like that. Okay, so that is it. So that's how we'll be moving in this case, because we might confuse things. It will be very big for us. So for this part now, I'll say I'll work with this part, and again I'll work on the what? Negative over x, like that. So for this part, which is here, I'll say this is just normal lim, okay, rim as h approaches what? 0. Then f of x, I'll just put the same thing, x plus h, alright, over what? H, like that. Then minus the same x, alright, the function. Then minus, alright, rim as h approaches 0, then of this one as well. So we have what? X plus h in the bracket there, then minus what? The same function, which is what? 1 over x. Okay, so this is how we'll be moving. So from there then we'll say lim as h approaches what? 0. Then this one, once we cancel the brackets there, you'll find that you will remain with what? H over what? H, which will give us what? Alright, we'll come to that. Then minus rim, okay. So here what is happening, that it's being divided by what? Everything is divided by h. So what I'm going to do is I'll say I'll group the like terms now. Alright, so the like terms now will be x open bracket x what? Plus h, like that. Okay, then from there what I'm going to do is, what is common there, that will give me x minus open bracket x what? Plus h like that. Okay, so here as lim approaches 0, so that is now the lim as h approaches 0, so that's 1. So that is 1, right? The derivative of a constant is the same constant, all right, like that. As h approaches 0, that is 1, like that. So forget about that one. That's how we get the lim from the first principle. So you divide that will give you 1. So then we have lim as h approaches 0, all right. So what we are going to do is on top there, I can simplify to say this is x minus x, then plus what? No, it's minus again, minus. That's h. This negative will multiply throughout everything. So now it will be negative h like that. All right. So I have what? X, all right, open bracket x plus h like that. Okay, so this one, for any information, the lim as h approaches 0 of a constant number is still that the same constant number, right? Hope that is clear. Then minus, let's work out this one. This one and this one goes, so remain with what? Negative lim as h approaches 0, all right. Then negative h, all right, over, so we put, so x, then open bracket x plus what? H like that. So now it's just a matter of replacing. So 1 there, then you put, now wherever there's h you put 0 and forget about the lim thing. Are you getting me there? By the way, there was something here, I haven't forgotten the thing which is dividing. This is just same as it dividing, right? H, which is just same as what? 1 over what? H, like that. So this h goes with what? That. So we'll remain with a negative on top, negative 1. Alright, so there's this negative there, negative 1. Then I'm substituting everything now. Alright, I'm forgetting even the issue of rim. Then I'll put what? Wherever there's h, I'll put 0. Alright, so this now goes as what? 1. This negative and that, it will give us what? Positive 1. Then over, all right, over what? That is just 0, so it will be just x squared like that. So this is the answer. So that's how we find the from the first principle, that's how we find the dy dx of that. All right. Okay, so now the other thing that we can talk about is one thing that is important. These questions are important, so we'll solve them. Don't worry, we're going to solve them. We'll solve all of the questions that you saw there in an exam. Those ones which are trick, we'll solve them. Okay, so now that we have solved that one, can we just also solve this one? All right, so can we also solve this one? We have, it's also trick, y is equals to x over what? X, so x over x minus 1 like that. So that's our question. So now using from the first principle, we are saying now this is how I'm going to solve this one. So I'll do this. I'll say y is equal to that x which is there, then times 1 over x minus 1 like that. Have you seen? So I'll make this one independent and also this one independent. So I'll say as lim, alright, h approaches 0, then of that, so I'll say f of x, so I'll just write x plus h like that because it's single, right, minus the same x, then over what? H, then times lim of this function now as h approaches 0, then I'll say 1 over, alright, so I'll put x plus wherever the x you put that change, then minus 1, then again minus the same function 1 over what, x minus 1, like that. All right, so we know this one as what, rem as h approaches 0, then we remove the bracket there, plus h minus x over what, h, then times, okay, times like that. As rem as h approaches 0, then we'll say what is common there. What is common there is x minus 1, right? Then there's x also, then I can just remove the brackets there, then it will be x plus what, h, then minus 1, like that. Okay, still the same thing, I just remove the brackets so that I combine these two. All right, okay, so from there then what we are going to do is, remember there is now on top there, then we'll have what, x minus 1, then minus 1 open bracket, this thing that we have there, which is just x plus h minus 1, like that. Okay, hope that is clear. Then what you are going to do is, we'll say here this one and this one, we can see they are going. All right, so now we'll say rem as h approaches 0, then we'll have what, h over h, like that. Then also this one is being divided by what, a certain h, so then that is what, times rem as h approaches what, 0, like that. So from there then we are going to say, we group the like terms there, so on top there we have x minus 1, then that negative will distribute there, that will be negative x, then negative h, like that, then plus 1, like that. Okay, so then over there we have what, x minus 1 open bracket, then x plus h minus 1, like that. Then it's being divided by, so I'll just say times what, 1 over h. You know the division thing. So here we say this what, a constant number, that will be 1, so we'll say rem of what, as h approaches what, 0, then that will give us 1. So a rem of a number is just the same number. All right, from that one, get that clear. Then from there, here we can see this one and this one goes. All right, then what else is going, this one and this one is what, going as well. So you are remaining only with negative what, negative, so we'll say negative h. So rem as h approaches what, 0, so remain with negative h over, all right, over what, x minus 1 open bracket, x plus h minus 1, then times what, 1 over h, like that. Okay, so from there then we said that's just 1. All right, so that is just 1. Okay, then times this one and this one goes, then it will give us what, 1. All right, so we'll say rem, okay, as h approaches 0, then there is negative 1 on top over, all right, over, then we have what, x minus 1 open bracket, x plus h minus 1 close, like that. Okay, then from there we replace now, so we'll say 1 times, all right, so there's negative 1 there over, so I'm replacing then everything now and remove this word rem, so I'll say that is what, wherever there's x, so here it will be 0, so it will still be the same 1 minus x minus 1, again x what, minus 1, because I've put 0 here. Okay, so this means that our value now, therefore, okay, so this will give us 1 times negative 1 is still negative 1 over, all right, these are the same, so say x minus 1, x minus what, 1, so that will be just negative 1 over, all right, x minus 1, there are 2, so I'll say squared, like that. So I'm done. So this is the dy dx of that question. Okay, then from there what we are going to do is, we can also have this one, so let's look at questions that are interesting. All right, so from now our question paper, all right, so this is the question I'm talking about. Okay, so we are going to solve these questions. All right, so I'm going to solve this question. Okay, okay, I'm going to solve these questions now. You have seen them. So the first question now is so these are the questions we are going to solve. All right, so these are the questions we are going to solve. So for your own information, I have the first question gives us um, what, differentiate using the first principle. F of x is equal to what? Absolute of what? X. So just to make you understand, absolute simply means the, suppose I have something like this. All right, so let's say this is the point. Okay, so this is, let's say, 0. All right, so I can have magnitude simply means the value can be on the negative or positive side. So the definition of magnitude is that they have two numbers. The magnitude value is just the value found on a number line. All right, so the value that you find, let's say you have a, then this is b. So let's say you want to find the values now. All right, so you say the value of let's say x can go this side, all right, or this side. Okay, so that's the meaning there. So now, since we can have these values on the number line as values of x, that's the meaning of absolute. There is a negative and also a positive. That's the reason why we are saying absolute gives positive or negative, and to understand this, why it is like that. So what you are going to do is, do you know that this f of y x is same as y is equal to what? Absolute of what? X. All right, so from there what I'm going to do is, for you to remove this absolute, you multiply throughout by what? By negative. By you square them like that. So here it will be what? Y squared is equal to what? X squared. Now you want to remain with just y. So what you are going to do is, you say, so before that I'm saying someone might be lost there. Alright, so y is equals to what? X magnitude, like that. That's the meaning there. So what I'm going to do is, I'll say y is equal to the same magnitude of x, then absolute value of x. Then what I'm going to do is, I'll square both sides, so that I square that, I remove that magnitude or absolute value. So what I'm going to do is, this is y squared is equal to what? X squared, like that. Then we multiply, we remove the brackets like that. So what I'm going to do is, I'll remain with that. So I'll just say I'm interested in y. So this is what? X squared. Now that y is equal to what? This absolute. So I'll put absolute value is equal to what? Root of x squared. So that is what the meaning there. So wherever there is this absolute in finding my differential equation, I'll put just root of what? 2. Hope that is clear and no one is confused there. Okay. Okay, that's mathematics, guys. We have no option. So we are now solving now in details. We said we said that x magnitude, like that, is same as what? Root of what? X squared. All right, so again, in terms of changing the other point, now the final in y will be what? The final in y will be what? The final in y, we can also have what? As the x approaches what? As it changes, then is equal to what? So is same as what? Is same as the, this is now change in y. So this can be what? This can be root of the same thing, x plus h, then open bracket squared, like that, just the same. So this is how they will be moving. So now from the first principle equation, so we're saying the dy dx of f prime is equal to what? Rim as h approaches what? 0. Then f of x plus h, right, minus the same function, then over h like that. So what you are going to do is lim as h approaches 0, then I'll put this one. Alright, so what I'm going to do is I'll replace that one as usual. Okay, so that is changing now. That's the second thing. So I'll put root of what? X plus h, then minus the same function now, which is just root x squared like that, over, alright, h like that. Hope that is clear. This is how we just, so you explain all those steps that I was writing. It's very trick question, but you just have to what? To understand it. And also we are solving this one, by the way, so you just need to understand it and also see what I've done here. It will be very helpful. You explain to say, we know that you derive what I've derived there. That's how we solve to convince lecturers, doctors. So now what you're going to do is we have this light, so I'm going to multiply this conjugate now, so that I cue some things there. So I'll say h as x approaches 0, then I'll multiply with the what? The numerator conjugate. So the numerator conjugate now will be what? X plus h open bracket squared like that minus squared like that, then over what? H, right? So times now the same thing there. So I'll say x plus h squared like that, then here it will be now plus x squared like that. Alright, the same thing you divide, right? There's nothing, it's more like you are multiplying the same number with 1. So x plus h squared plus root of what? X squared. You see, this is just 1, right? This is just 1. So we are just playing with mathematics there. Then from there, then what you are going to do is we'll say lim as h approaches what? 0. Then this one is just the difference of two square. Now we can see positive and negative, so we'll just square those ones. We'll kill these in short. Alright, so we'll remain with what? X plus h squared, then minus the same thing, which is just now x squared like that. That is if we cancel. Alright, then over h open bracket, this one will now remain just the same thing. Alright, so x plus h squared plus root of what? X squared like that. Okay, so we are done like that. Then from there, what you are going to do is we'll say lim as h approaches what? 0. So there once you expand on top there, to be x squared plus 2xh, then plus h squared minus x squared, then over. Alright, so remember, okay, there's h down there, open bracket, then root of x plus h squared like that minus plus no, then x squared like that. Okay, so then from there I'll start from here. Then from there, then we can see this x and this x goes. Alright, we just remain with what? 2xh plus h. Alright, then the lim word I'll bring it later. Allow me, okay, let me just put it for the sake of cases. So then I'll say lim as h approaches 0, then I'll say h open bracket root of x plus h squared like that. They are all in the square thing, then plus root of what? X squared like that. So now I'm factorized, so I'll say lim as h approaches 0, then I'm factorizing. What is common there is h. H is common, guys, so I'll say h open bracket So that will be 2x plus what? 1, like that. All right. Then down there we have h open bracket root of what? X plus h open bracket squared minus x squared. That, by the way, that is plus. Then this and this can go, you can see. So remain the 2x plus 1 on top there. Alright. So I've forgotten one thing here. This is squared. Alright. So the h is squared is now h, which is remaining there after factorizing, right? So that is h. Then from there, then what we are going to do is we'll replace now the word h and remove the word lim. Alright. So I'll put what? 2x plus what? 0 over. Alright. Over what? Inside there we have what? X plus 0 open bracket, then squared plus x what? Squared, like that. So you